All right, here's a little practice with handling exponents. This topic comes out of Chapter 5 in your textbook. One of the properties of exponents that we will use pretty much exclusively in this problem is the property that tells us what to do when we have a division containing expressions that show a common base but constant value exponents. So a variable raised to a constant, those two in a quotient like this. What we do here is we end up doing the difference of the exponents. So for example, 5 to the 5th over 5 squared would be 5 cubed. And that's because there's cancellation. If there are this many repetitions of x on the top and this many repetitions of x on the bottom, a whole bunch of them are going to cancel out down the line until you're left over with whatever the difference between the exponents is. So when we take this over here, let's first recognize that all the joinings between these mini expressions are all multiplications. So we can treat this as 12 over 6 times x to the negative 2 over x to the 4th times y cubed over y to the negative 4th, and then handle each of the quotients individually. 12 divided by 6 is the easy one. That's 2. And then this quotient, when we use this property, will reduce to x with the exponent of negative 2 minus 4. And then in the last part, we will have y with ultimately the exponent of 3 minus negative 4. So be careful there. You have to track those minus signs well. And that net result is 2 times x to the negative 6 times y to the 7th. And if you don't like negative exponents, then what you can do is move that x with its exponent into the denominator where the exponent is now positive. Either one of these are perfectly good expressions that represent the simplified version of the original function. And maybe you're asked to produce one form or the other. You just have to know how to go back and forth and how to recognize they're the same.